Okay, so now we're on page 235, and we're talking about taking the trig value, or the trigonometric function of any angle. And when we started doing trig, we talked about how sine was y over r and cosine was x over r. But what happened was we started trig with the unit circle. So if I have some circle, and this is the angle theta right here that I have, on your unit circle you had some ordered pair here. And so if you were asked cosine of theta, this angle right here, you were just giving us the x piece. But really you were giving us x over r. And what happens on the unit circle is that you have x over 1 because the radius is 1, so it comes out to just x. What's going to happen now is that we're going to leave the unit circle and we're going to have any point xy on any circle, which means that we have any radius. So we're going to use SOHCAHTOA because it works with right triangles and Pythagorean identity, and we're going to find the value given any ordered pair on any circle. So first things first, I've taken a big yellow highlighter and highlighted these 6 trig functions. You have to know these definitions. You have to know that sine of theta is y over r, and cosine of theta is x over r, tangent of theta is y over x, and then I drew blue arrows down because these are reciprocals. So if you know that sine is y over r, and you know that sine's reciprocal is cosecant, then reciprocate or flip this and you get r over y. Cosine's reciprocal is secant, so r over x, and tangent's reciprocal is cotangent, so x over y. So what we're going to do is, and what you're going to spend a lot of time doing, is the following. You're going to be given some point like you are down here on the bottom of the page. So I'm going to be given a point 3, 4, so always step 1 is draw it. So I'm going to go over 1, 2, 3, and down 1, 2, 3, 4. So I'm like right here. This is my ordered pair. And when we go around the circle, we rotate in this direction. We rotate counterclockwise. So this is the angle that I have. You are always, I can't say it enough, always going to make a right triangle with the x-axis. So I have this piece right here, and this piece right here, and the ray, or the angle that I use to rotate, is making my hypotenuse. I know that this distance here is 3. I know that I've gone down 4, and since I have a right triangle, I can use Pythagorean theorem to find the radius. So Pythagorean theorem says that a squared plus b squared equals c squared. I'm not going to use a squared, b squared, and c squared. I'm going to use what I have here, and this length, or this 3, is x squared, plus this is y squared. This is going to equal my radius squared. And this was the equation of the unit circle, assuming that r was 1. So now I'm going to plug stuff in. X is 3, so 3 squared is 9, plus y squared is negative 4, or y is negative 4. Negative 4 squared is 16, and that's going to equal my r squared. So I get 25 equals r squared. You're going to take the square root, and in this case we only need to worry about the positive version because we're not going to have a negative radius. So r is 5. That's step 1. You have to always have x, y, and r. So now that I have x, y, and r, I can go through and find the trig function. So down here, sine of theta equals, sine is y over r, so negative 4 over 5. And then cosine of theta equals x over r, so 3 over 5. And tangent of theta equals y, which is negative 4 over 3. I always do these 3 first because now I can just do their little friends and not have to do a lot of math. Cosecant of theta, I'm just going to flip that fraction over, so it's going to become 5 over negative 4. Secant of theta is going to be 5 over 3. And cotangent of theta is going to be 3 over negative 4. And so there is your answer. One quick little note. If you get a square root down here in one of the denominators, you have to rationalize your fraction. You cannot leave a square root down in the denominator. So now we're going to go over to page 236, and it's another example problem, and it says, given that tangent of theta is negative 5 over 6 and cosine is greater than 0, find sine and secant. Use the information you are given. Okay, so here's what we need to do. We're going to just kind of decode. So I told you in the last problem, to do any one of these problems, you had to know x, y, and r. Well, you're given x and y in this case, you're just not given it in the form that you want, an ordered pair. See, they're telling me that I have a negative 5 over 6 And we know by definition that tangent is y over x. So y is 5 and x is 6. But you have to decide who gets the negative sign. Well, that's what this piece right here is for. It's telling you that cosine of theta is greater than 0. So that negative sign has to go with the y because the x part, or the cosine part, has to be greater than 0. So we now know that the y is equal to negative 5 and x is equal to 6, which means you have the ordered pair 6, negative 5. Oh, sorry, there you go. 6, negative 5. And so again, we can draw it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Again, we're in the fourth quadrant. We have this triangle right here. 6, negative 5. So I'm going to do 6 squared plus negative 5 squared is going to equal my r squared. So 36 plus 25 equals r squared. You're going to get 6 square root of 61 equals r. So now that I know all of that, I can find sine and secant. So sine's definition is the y, negative 5, over the r, which is the square root of 61. And like I said earlier, you cannot leave the square root down here, so you're going to rationalize it by multiplying by the square root of 61 over the square root of 61. So your answer for sine is negative 5 square root of 61 over 61. And then for secant, secant of theta is going to equal my x piece, which is 6, over the square root. Oh, sorry, nope, backwards. Secant is not x over r, it's r over x. So I'm going to take my r, square root of 61, over my x, which is 6. So this is my answer, and that's my other answer right there. So what you're going to do now is you are going to stop the video, you're going to try the next 3 problems, and then go back to Edmodo and check the next 3 problems and see if you got them right.